So, hi guys, my name is Ruthvik, and in this session, I'm going to discuss the problems from Codeforces Round 1078 Div 2. So, coming to the very first question, the name of the question is Lawn Mower. Here we have a fence consisting of N boards and 1 meter wide, and we have a lawn mower on plot that is W meters wide. So here the lawnmower will be able to exist the plot if there are at least W consecutive removed boards among the list of removed planks. And we have to determine the maximum number of boards that can be removed from the fence. I will summarize this question once. Like here, what we basically have is that like we have a fence consisting of N boards, 3, 4, so on till N boards, and basically every board is 1 meter wide. And we have a lawnmower of size W. Let W equal to 3 in this case. So we are allowed to remove any number of fences from the list of N fences. And if we remove, for suppose if we remove some fences greater than or equal to the size of lawnmower, like if we remove 4 of the fences, then the lawnmower can freely move outside, right? So we have to determine the max number of fences that we can remove such that lawnmower can't move outside, can't move out. Like for example, instead of 4, if I remove only 2 fences, here the lawnmower will be unable to move outside because the size of the lawnmower is 3 and I have removed only 2 fences. Or in the case if I remove only one fence, in this case also the lawnmower can move outside. But if I remove any number of fences that is greater than or equal to 3, the lawnmower can move outside. The fences can also be somewhere here. Like for example, I have removed 2 here and 3 here. The lawnmower can move outside from here as W equal to 3. Okay. So here the main like the initial observation is that let's suppose these are the N fences. Like let's solve for a small case where N equal to W. If the value of N equal to W, then the maximum number of fences I can remove is, then the answer will be W minus 1. Because if I remove W minus 1 fences, then my lawnmower can't move outside. Because for my lawnmower to move outside, I need a space of size W. So answer will be W minus 1. After making this observation, what we can do is we can divide the given n in blocks of size W. Blocks of size W. And what we do for each block of size W is that we remove maximum number of fences possible from each block. Like for example, I have some 3 blocks of size W. I will remove W minus 1 from here, W minus 1 from here, so on. I let this be our n value 1, 2, 3, 4, 5, 6. Let the value of n be 12. And for n equal to 12 and W equal to 3, I'll initially make blocks of size W. And what I'll do is I'll remove W minus 1 fences from each block. So I'll keep this fence. And in the case if I have a reminder, like for example, if the value of n does not divide W, like W does not divide n perfectly, n modulo W is not equal to 0. In that case, what I'll do is I can simply remove the remainder because uh, n modulo W is always less than W, and the lawnmower can't move outside from the remaining blocks. So what I'll do is initially, uh, initially I'll take the floor division n by W. I'll get the number of blocks. I'll write the symbol of floor division n by W. I'll get the number of blocks. And after getting the number of blocks, I can remove W minus fences from each of the block. And plus, if there is any remainder equal to n modulo W, I can simply remove all the blocks from the remainder. So that's all. Coming to the code, here initially these are the number of blocks n by W, and this is the remainder of n when divided by W. Our answer will be simply the number of blocks into W minus 1, removing W minus 1 from each block, plus the remainder. And that's all. So coming to the second question. So here Mark stores his, okay, Mark keeps most of it in the bank. Like Mark's love money very much and he keeps most of it in the bank. He stores his money in n different banks. In the ith bank, he has AI rupees or we can take anything, AI money. So here Mark decided to gather all the money in one bank. So he will be transferring money from one bank account to another. But here he has a constraint. He can only transfer X X from one bank to another, and after transferring X, only Y will be deposited or Y amount will be credited to the another account. Okay, like basically what's happening here is that let's suppose he has n banks. Okay, n banks. Here, if he takes X rupees from one bank, he can take out X rupees from one bank and put it into another bank. But but due to transaction fees, the amount that is credited in the bank he deposits will be Y. Okay, and they given that Y is less than or equal to X. So basically, from any bank, if he has M amount and like suppose if he has there are two banks A and B, what he can do is he can remove X from A and after transferring the amount Y will be credited in B. And we have to note that he can remove exactly X from A, exactly X and exactly Y will be credited, like no less or no more than X. Okay. Now, what he wants to do is he wants to find the maximum amount that can end up in any of his banks finally. Like, suppose he has n banks, right? He has n banks. So finally, he wants to know the maximum amount that can end up in any bank. Like basically, if I choose this to be a final bank, he will transfer all the amounts from other banks to this bank. Or intermediate transfers is also possible. Like for X, if this is the final bank, I will transfer Y to here first, and then again I'll transfer everything from this bank to this bank. Okay. So finally, we have to find the maximum amount that can be obtained from any bank. So here, the first observation will be something like this. Like let's analyze if, like suppose we'll start by fixing one bank as the final bank. Okay. Let's analyze the case, like if it is beneficial for us to transfer from if the like let C be the final bank and let these be a bank A and B. Let's see if it is beneficial for us to transfer some amount from A to B and then to our final bank C. What will happen here is that I'll tell it with an example. Here the value of x is 5 and y is 4, right? X equal to 5 and y equal to 4. So if I transfer from bank A to bank B, mm, there will be loss of -1 here, right? And if I make a second transfer, I will incur another loss of -1. So if I make two transactions instead of one single transaction, like what's happening here is x equal to 5, y equal to 4, right? If I make a transaction, I will lose one money. So from here, we can see that it's always beneficial to make one transaction instead of making two. And even this is the case when x is greater than y. When x is equal to y, then there is no losses, right? Because if I transfer from bank A to B, my loss will be zero anyways. So here in this case, if I am like if the value of x does not change even after any transactions, then what I can simply do is instead of sending the amount from bank A to bank B, then to bank C, what I can directly do is I'll directly send my amount X to the bank C itself. Like this doesn't make any difference, right? So here the main observation is that I can if I select a final bank, then I can collect all money from other banks in one transaction. Like basically one transaction in the sense there are no jumps in between. So here, like let's suppose uh, my final bank is some bank C and I have amount A in bank A. So the maximum amount that I can send from bank A is that I'll take the float division. Like in each transaction, I can send exactly X rupees, right? Into the amount that will get credited in bank C. So from bank A, I can send a total of this many rupees to bank C. Similarly, for any bank, I can send this much amount to the final bank, right? So what we can do is we can iterate over all banks to let's say iterate over all banks and assume that they are the final bank. And what we can do is after fixing a final bank, we will transfer all possible money from remaining banks. So basically what I'll do is if I have some n banks, I'll fix one bank to be the final bank. Basically, I will iterate over the final bank, and after fixing one, I'll transfer all the remaining money from the other banks, maximum possible money which I can transfer from other banks. Uh, that's all. I'll explain the remaining part from the code itself. So here, like initially I'm taking the input and I am calculating a total value. Like if I iterate over all the banks in given array, the amount I can transfer from a bank, let Z be the amount in the current bank. Z is the amount in the current bank, and the amount I can transfer from that bank will be Z by X into Y. Like here, as I have described here, basically A by X flow division of A by X into Y. Okay, so I am adding the total. Like I am assuming that I am transferring from all the banks initially. So the sum I have stored the sum in this variable, and coming to the answer, I have initialized the answer to be 0, and I'll iterate over all the banks. So and I will remove the current sum from the sum. I will remove the current transaction amount of the bank. Like basically, why I'm doing this is that I will keep the money in my current amount as it is. So I am removing this part from the total, and I'm adding the value z. Like what happens here in total minus current is that initially I am adding all the values in the variable sum. Now if I remove, uh, let's suppose initially sum contains the transfers from all the banks, and if I assume that this is my final bank, what I'll do is I will remove this value from the sum and add the initial amount z in the current bank. Sum minus transfer amount from this bank, that will be z by x into y plus z. Z is the initial amount that is already there in the bank, and the remaining amount that will the amount I will get from the remaining banks. So this is the answer for the case where this specific element is the final bank, and I am taking the max of answer over all possible values of z. And finally, I am printing the answer, and that's all. So coming to the third question, Bob is a spy and has intercepted an encrypted message. He assumes that it contains secret information and is actively engaged in deciphering it. The note contains k strips, each of length n, and each of the strip contains only strictly contains lowercase Latin letters. So the Bob guessed that the message he is interested in is also a string of length n, and ith letter of this message corresponds to ith letter of one of the strips. So what we have here is that we have k strips, each of length n, k strips of length n, and the ith character, and also we have a code. Basically, the ith character in the code is any one of the character at the same position in the strips. Okay, like suppose let this be A, B, C. So this first character can be A or B or C, any one of these three characters. And also the inform he has also defined a function informatory of a string, which is the minimum possible positive integer t, such that a string t of length d exists, and s can be formed by repeating t several times. For example, like the value of function of this string containing four a's is 1, because what I can do is I can simply have a letter A and repeat it four times to get this string. And the value of function of this string AB is 2, because this string can be formed by repeating AB two times. And similarly, the value of this string is 4, because uh, basically we can't form this string by repeating any other string. So the value of this string is 4 itself. That is ABCD. Like I'll repeat this complete string one time. Okay. Now our goal is to find the message that represents the decryption. That is the final code word, and it has the value of this informativity, minimum possible informativity. Like the value of this function must be minimum possible. So I'll initially draw the case strips. Here there are case strips, and let this be the final code word. And what we know is that, like if we pick any I, the value here can be any one of the values which are present at that index in the case strips. Okay, so let's focus on the function that they gave here initially. For a string s, the value of the function is the minimum size string t, such that s can be formed by repeating t some k number of times. Okay, from this, what we can observe is that let the length of the string s be n and length of the string t be m. So the length of string n will be equal to m into k, right? If we repeat the string t k times. So here m is a divisor of n. So from this, our next step will be as follows. As the number of divisors of n will be in the power of n power 1 by 3, like will be in the order of n power 1 by 3, we can simply iterate over all possible values of m, and like we can iterate over the divisors of n in increasing order and solve for each divisor of m, sorry, n, each divisor of n. Okay, and here we are going in increasing order. Solve for each divisor of n. For every divisor of n, the idea will be as follows. Like let's suppose this is a finite string of size n, and if our code word is of uh, if we are at a divisor, like what is the 1 2 3 4 5 6 7 8 9 10 11, or we'll take it 9. Here the value of n equal to 9, and let's suppose I am at a divisor 3 of 9. So if I am repeating my code word 3 multiple times to form this string of size n, uh, we can see that the keyword at position the keyword at index 1 is same as that at index 4, and that will be same as the keyword at index 7. Basically, if the indices differ by 3 or a multiple of 3, the words should be same, because I am repeating the same string from here. So what I have here will be exactly present at this position also, and that will also be present at this position. Okay. So keyword at 147 are same, character at 147 are same. Similarly, 2, 5, 8 are same, and 3, 6, 9 are same. Basically, I'm incrementing this with the size of my string t. Okay. Now what I have to see is that if I fix a divisor of n, let's suppose 3 in this case, what I'll see is that for every index that is in this set, or the numbers that are in this set have same modulo when we divide by 3. So every number in this set, I will check if it is possible to place a same character at every index that is in this set. So that how can I check that is that initially I have case strings, right? So for every index I, what I'll keep a note of all characters that are present at that index. Like for example, uh, I can more efficiently store which characters are present at every index by using a bit mask. Like initially mask is 0. If there is a character, if there is a character C, C is the third character, right? So what I'll do is I will take the OR of mask to C character C minus character A. This will be 2. So basically what I'll do is if there is a character X at a position I, what I'll do is I will iterate through all the strings K and take bitwise OR of all the corresponding power of 2 of that character. Like let's suppose if my position I has character A, C, D, E, what my mask will look like, mask will look like as follows. I let this be the LSB. It will be 1 here because A is there, 0 because B is not there, CD it will be 1, and 0 at all other characters. Basically, at every index, what I can find out if a character is present at the at that index or not in all the case strings. So after making a mask, what I'll do is I have formed this set, right? I will check for every element in this set. I have the mask values for every element j in the set. Here the j values are 1, 4, 7. And I will take the bitwise AND of all these values. What bitwise AND will do is, like let's suppose if I have masks as follows. So if I take the bitwise AND, the only bit that stays on is the bit that is present in all the numbers which I have taken AND. So I'll get a 1 or I'll get a value greater than 0 only if there is a common bit in all the case strings. So I'll take a bitwise and check if it is greater than 0. If it is greater than 0, then that position will be safe. Like basically, I can have a common bit for all the elements in this set. If that is not greater than, if that is less than or equal to 0, then I can't have a common bit at that set, right? So I will proceed with next bigger divisor of n. So for every divisor, I'll check this as follows. And if this condition gets satisfied for all the elements in a set in a divisor, then I'll simply print that divisor and I will print the element which satisfies that condition at every index. I'll explain this with the code. So initially, I have pre-computed all the divisors up to 1e5. So coming to the input, I am taking n and k, and also I am taking k strings as input. Here I have created an array of strings and I am taking that as input. And I have created a mask for every index I. And what I'll do for every index I is that I'll iterate through all the k strings, and I will check if I'll take the bitwise OR of that corresponding character to the mask to the current mask at index I. So my next step will be iterating through all the devices. Here the devices will be initially stored in increasing order only. So we don't need to worry about sorting. Iterating through devices, what I'll do is I will initially check, like here, let the divisor size, let the current divisor be X. So what I'll do is for every index from 0 to X minus 1, I'll keep on doing plus X, as these will be the elements in the set, and what I want is they should be same, right? They should have the same value. So for every number in 0 to x, I will basically I will basically increment it by x and take the bitwise AND of the mask at that index. And I will keep on doing this until the value of my j will be less than n. So if my current, after taking bitwise AND, if my value of current is 0, then then this x can't be the answer, right? So what I'll do is, if the value of current if is 0, I will switch this flag to 0. I'll set this flag to 0. And if the flag is 1, then I have an answer. If it is 0, then what I'll do is I'll simply continue with the next divisor. Now coming to the case where the answer is 1, what I'll do is my string answer equal to, I'll initially it will be an empty string. So the value of current, I have recalculated the value of current by taking bitwise AND from all the elements, and the value, and I have extracted the bit which is 1 in the current, which is set 1 in the current. Like let's suppose if it is at an index k, the value of character will be a plus k, and I am adding this to the answer. And number of times I have to repeat the answer will be n by x. Because I am taking the size of the string t as x, I have to repeat it n by x times in order to form a string of length n. So I am printing that the value answer n by x times, and I am returning. That's all. So coming to the third question, the name of the question is table cut. Here we are given a table of size n into m, and initially each cell is either 0 or 1. Our task is to divide it into two parts with a cut, such that it goes from top left corner to bottom right corner, and the cut lines can only go right or down. Here, let A be the number of ones in one part of table and B be the number of ones in the second part. Our goal is to maximize the value A into B. Like let's take, uh, I will go through one of the examples. Let's take this test case. Here, what they are doing is, this is the current table, right? So they are cutting it as follows. Like here we can go only right or down, right or down. Okay. So they have cut it as follows. And in the left part, there are 1, 2, 3, 4, 5 ones. And in the right part, there are, oh, sorry, in the left part, there are 6 ones. 1, 2, 3, 4, 5, 6. And in the right part, there are 5 ones. So the answer is 6 into 5, that is 30. And we have to also output the order in which we are going. Like here, right means we are initially going right. Second character is D. We are going D here. right, down, so on. So here the initial observation should be as follows. We are cutting the given grid into two parts, left and right part, right? Here, what I am claiming is that left part can contain the number of one. Let the total number of ones be uh, t. Okay. Or we'll start from here. Let x be the number of ones in the left part and y be the number of ones in the right part. Okay. Here, x plus y equal to t. T is the total number of ones. Total number of ones. So what we have to maximize is we have to maximize x into y. So here, for getting the maximum value of x and y, the values of x and y should be as close to t by 2 as follows. Like x equal to floor of t by 2 and y equal to ceil of t by 2 in order to get the maximum value of x into y. This can be proved using the inequality arithmetic mean is greater than or equal to gm. Using this inequality, we can prove this one that x and y should be as close to t by 2 as possible. So this is the first observation. And coming to the second observation, what I can say is that I can have any number of ones as I wish. Like from 0 to t, I can have number of ones from 0 to t in my left part, right? I can have any number of ones from 0 to wish. Like I can find a cut such that it has exactly x ones, and the value of x can be any number that is in 0 to t in my left part, x in left side, such that it is 0 to t. How to prove this is that, like, let's suppose I want to have only one uh, in my left part. So what I'll do is I'll go down till I encounter a 1 here, like till I encounter my first one. Like for example, there is a first one here. I'll go right here and I'll then again go down. Now, if I want two ones, what I'll do is I'll repeat the same process again. Like again, I'll check for the first one, bottommost first one. So in this case, the bottommost first one will be here. So what I'll do is I'll initially go right and go down until I reach the bottommost first one. And after I reach it, I'll go right again and come down. So similarly, if I want the answer 3, what I'll do is I'll check the remaining ones, and this will be the bottommost first one, right? Let there be any ones here. So instead of, I will turn right here and again go down. So here we can note that we can have any number of ones in my left part as I wish. And in the case where I want 0 ones in my left side, what I'll do is I'll simply go down from first itself. Like I'll simply go down and go right. Basically, I have nothing in my left part. Left part is empty. So this is the second observation. Now, what I'll do is that I have value t, right? So I'll keep exactly t by 2 ones in my left side. So for keeping t by 2 ones, the last one will be the bottommost if we sort all the positions of 1 by the bottommost element, like for example, initially the first one we encounter at the bottom is this one, and second we encounter this, and third we encounter this. Basically, the one initially we have to sort by, let's suppose they are given in the format Aij, right? I is the row number and J is the column number. So sort by row. The bottommost one initially has is the one that has the lowest row number. Or am I wrong? Oh, no, no. Exactly. We have to sort by column because this is the column 1, this is the column 2, column 1, column 2, so on, right? So initially the bottommost one has the lowest column. Then we sort by row. If we do this, we'll get a ordering of ones. Like for example, here this is 1, 2, 3, and after that we'll get this as 4. Okay. Now after that, our next step will be if the value of t by 2, after getting the value of t by 2, let the value of t by 2 be 4 in this case. Here, let me put some more ones. 5, 6. Oh, sorry. 5 will be here, and this will be 6, and this will be 5. So, if the current value of my t by 2 is 4, what I'll do is I will initially keep on moving right. This is my desired column, right? So, I'll initially keep on moving right till I reach my desired column. Right, right. Till I reach before my desired column. After I reach before my desired column, what I'll do is I'll start moving down and I'll stop before I reach my target. This is my target, right? 4. So after reaching correctly above this, I'll move right again and again I'll start moving down. And finally I'll go as many right, which is left over right. So that's all. We have to implement this in the code. First move right, then down. After reaching my current target, I'll move right again, and then I'll again move down and I'll move right. So how I am doing that is after taking the input, I am pushing the element I comma j. Like if the current element is 1, I am pushing its value in a vector, and then I am sorting the values in this vector of pairs. By initially, I am checking if the column of the left is less than right. If both are in the same column, I'll take the one that has the highest value of row. Like for example, if we have these two, I'll take some another color. If we have this and this, both of them have same column, but the value of row numbers will be from here, right? This is row number 0, this is row number 1, 2, 3, 4. So, uh, after sorting by column, if both of them are in the same column, the one which has the highest row number will get the lower value. So, here the one that has the higher row number will get the lower value. And after that, I am finding the size of the vector and the number of elements I want to have at my left part is size by 2. If there are 0 or 1 ones, then my answer will be 0 because if in either of these two cases, we are forced to have a side where we have 0 ones. So our answer will be 0. And in the case of 0, I'll fully go down, and next I'll fully go right. And I'll print it and I'll return. If I have a valid answer, if I can form an answer which is greater than 0, what I'll do is the candidate which I'm going to choose is at an index best minus 1. Basically, let this be I want to have size by 2 number of elements, right? So the last element will be size by 2 minus 1 because I am taking it 0 indexed, and this will be the size by 2th element in this vector. Okay, so my answer will be uh, the value size by 2 and the remaining product of these two. Basically, seal of size by 2 and floor of size by 2. I'm taking product of these two. After that, this is the row and column of the current candidate. What I am doing is initially I will if the candidate is at column Y. So what I am doing is I'll initially go right till I reach the column of the candidate. This is the Y is the column, right? So initially I'll go right till I reach column Y. Here I am going right. And after reaching just before the column Y, here we have to note that Y is 0 index. So if this is the third column, the value of Y will be 2 right. So I will go only 2 times to the right if I run a for loop 0 to Y. So coming 2 times to Y is first time I'll come here, and in the second right I'll come here just before the column Y. And after reaching there, I'll start going down till I reach the row X. Okay. After reaching the row X, what I'll do is I'll go to right once. So here I am going down. I'll take another color. Here I am going down till I reach the row X. After reaching the row X, what I'll do is I'll go right once. This is the row X. I'll go right once. And after going right, then I will again continue going down. I'll continue going down. And after reaching to the very bottom, I'll go to the right. And in this way, I have formed a cut. And finally, I'll be printing this. Yeah, and that's all. Coming to the fifth question. Here we are given a rectangular pizza consisting of n rows and m columns. Okay. Now here each slice has an unique recipe and flavor. Here what we have to notice, we have a pizza which has n into m slices. Okay. And each slice has a flavor which is denoted by a of ij. Now what he has to do is Michael would eat first, and according to that, what he will do is he must choose a route from top left corner 1, comma 1 to bottom right corner n, comma m. Like basically we have this pizza. So Michael will initially choose top left corner and he will go to this bottom right corner. And he has to choose a route and he can only go either right or down. And Michael aims to maximize the total pleasure from the eaten slices. However, the second person decides to use a sauce before Michael chooses a route. The what she does is that she chooses exactly one slice of pizza and apply the sauce to it. What this will do is that it will change the pleasure of that slice to its opposite. Like for example, initially, if previously the value of slice is aij, after applying the sauce, its value becomes minus aij. So Michael wants to maximize the sum of the values in his part. Like for example, if he chooses a path, he wants to maximize sum in that part. And what the second person wants to do is that she wants to minimize the sum. Like she can choose a cell ij and change its value to minus ij, and her main goal is to minimize the final sum. And she can do this operation exactly once. So for each test case, we have to output the minimum pleasure Michael can achieve. So here I'll go through one of the test cases. Here what Michael can initially do is that he will go straight, and from here he will go down. So the value of sum will be minus 3 plus 1 minus 2 and plus minus 1 will get a value of minus 3. And if the second person applies the sauce here, the value here will be minus 1. So the final value will be uh, the grid contains all minus 1. So Michael can achieve the value minus 5 only. So coming to the explanation of this question, here let this be the grid, and let's suppose if the second person chooses a grid here to apply the sauce. Initially, uh, Michael has a best path, right? The path that has the maximum sum. So, if the second person applies sauce anywhere that is not in the path, Michael will simply again choose the maximum path here. Or, uh, or he can also choose this one if the value of sum can increase. Okay, the path where the sauce has been applied. So, in order to minimize the sum Michael achieves, we have to choose any one cell that is in the path which gives the maximum sum. Okay, this is the first observation, but I guess this won't be necessary because what we are going to do is we will iterate over all cells. Like we are applying the sauce, right? In order to for applying sauce, we'll iterate over all cells and then calculate the max possible sum after applying sauce to that cell, and I will take the minimum value. Like basically what I'll do is first I'll select one cell and I will assume that I have applied the sauce there. And after applying the sauce, I'll calculate the max possible value Michael can have. And over all the n into m cells, I will finally select the minimum possible value. So for doing that, we can do this as follows. Like let's suppose we have a grid here, and in case if we apply source here, so the new value will be like the sum over all the parts that do not contain this cell, like maximum value of sum over all parts that do not contain this cell, don't contain max val of sum of parts that do not contain the current cell, let the current cell be x, and max possible val of sum over all parts that contain x. And what I'll do is I'll take the maximum of these two values. So how to find the max possible, how to find this is that, like initially, I will maintain a DP array, DP of I comma j. What that will calculate is that, like let's suppose this is the value of I comma j. It will calculate the maximum possible sum such that I finally end up at cell I comma j. Okay, let this be the DP1. Finally end up at cell I comma j. And next what I'll do is I'll also calculate another DP. Let this be DP2. What this will contain is that from I comma j to and I am starting from I comma j and to end up at the final cell, what is the max possible value of sum? Initially, this contains the max for possible sum from 0 comma 0 to I comma j, that is the start point to the current index. And this contains the max possible value of sum from I comma j to end point. Endpoint will be n minus 1 comma n minus 1 if we take 0 indexed m minus 1. From here to here, and both of them contain the max possible value of sum. Okay. So here, after defining these two arrays, what I'll do is that if I have a current element x occupied, then all the paths that do not go through x will be as follows. I'll initially remove this. So the path can either pass from before x or it can pass after x, like something as follows. If we consider only the row in which x is there, the path can either pass from any cell which is before x or it can pass from any cell that is after x. Okay. So in order to calculate the maximum possible values, I will check the maximum possible value of a path that can pass through this cell, and it can only access the cells that are before the current column. So for that, what I can do is that I will simply, if I have this current cell x, or I'll rename this value as y, max sum such that it only passes through cells to left of it. Like before it crosses the current column, it has to only pass through cells to left of it. Like for example, it can come like this and pass through Y. And after passing through Y, it must go down. Like it can't go any further. So I will calculate the max sum for all paths that are like this. And how I can do this is that, so if I am at a current cell Y, I can either enter y from the top or from the left. So what I'll do is from either I can enter y from either top or left. So what I'll do is basically the dp1 value of this top cell and dp1 value of this left cell. Whichever is maximum, I'll take that value, max of these two, plus I will add the value of this cell, plus my next step will be I'll only go down, right? So plus I will add the value of dp2 of the bottom down cell. Basically max of these two plus the value of the current cell a of y plus the value of dp2 of down cell. What this signifies is that dp1 tops contain the max possible sum in order to reach this top cell, and this contains the max possible sum in order to reach the left cell. And after reaching these two cells, I will go through this cell y. And after that, as I have discussed before, I can't go any right. So I'll go down. So dp2 down contains the max possible value of sum if I go from this cell to my final destination. So this will be the value for each y. And what I'll do is I'll calculate this value for all the elements to the left of x and all the elements to the left of x. And I'll take the maximum among those values. Basically, I'll calculate this value and take the max. Okay. Similarly, I will do for what I'll do for right is that for left, we can either approach from top or left, right? In the case of right, what I am doing is that I can approach from top, but I can go to, uh, I can approach from top and I can go to right or down. Because if I keep on going to left, I may cross X, right? So I'll approach from top and go to either right or down. So similarly, in the case of right, here what we'll do is we will take dp1 of top and take max of dp2 of right, comma dp2 of down, and the value will be as follows. So for every x, what I'll do is I will take the max of this left possible and max of these right, and what will the max of these two values, max of left and max of right, max of these two values will give the max sum of path uh, which don't step on X. So in this way, I'll calculate this second one, max sum that do not contain X. And coming to the paths, this one has been calculated. And coming to the case where we have to calculate max sum that contains X. So what will happen here is that uh, if I am max sum that contains X, if I am at element X, Hmm, I'll explain here only. If I'm at a element x, I can either approach x from top or I can approach either I can approach from top or approach from right. and I can approach from top and left, top, left, and I can leave from X to right or go down. So these are the four ways. So what I'll do is I'll take the max of top comma left and add the value of X, Aij, and next I'll take the max of down comma Y. In this way, I will calculate the max value of sum that contains the element X. So for every X, I will take the maximum of these two values, and my answer will be for every X, what I'll do is I'll take the max of uh, containing X and not containing X, no X. Max of X and not containing X. And out of these values, this is the max possible value of sum, max possible val of sum if uh, if I apply Saucet X, right? Basically make X Aij to minus Aij. Okay. Here we have to note that in the second case, I have to add minus Aij because we are applying sauce here, right? So max of these two plus negative of the value at this cell and max of these two. And after getting these maxes, what I'll do is I'll finally take the minimum of all possible answers. And that's all. So coming to the code. So initially what we are doing is here we are calculating the values of dp1 and dp2. dp1 and dp2 have been already defined here. dp1 is from 0 to 0 to I comma j and dp2 is from I comma j to the bottommost cell n minus 1 m minus 1. We are calculating those values. Okay. And the transition will be as follows. dp1 of I comma j is that from every element we can either enter from top or left. So I'm taking the max of those two values and I'm adding the value of current element. Okay. Similarly, we are calculating the value of dp2 and after calculating these two values, what we are doing is that initially uh, for every row, I am maintaining the left and right values. Basically, the ones that I have told here. Like for every row, I'll take this color. I'm maintaining this left value and these right values. Basically, the left and right values from every row. And while calculating the left value, what I'm doing is I'm adding the value of Aij. I'm passing through current element and max of top comma left. Either I can enter from top and left, and after that I can go only down, as we have discussed earlier. So that will the value of the current element at index j. And I am doing this for all indices j from 0 to m in the row I. And similarly, I am calculating value r. R means we are entering only from top and I can either go right or down. So I'm taking max of these two and I'm entering from top. And what I'm doing here is that current for every j, I am taking the maximum of L of all the previous values. Similarly, I'm doing it from R also. R of j contains the maximum of all possible values that are to the right of it. Okay. Now here the value best ij contains the best value of path. Like basically if I have aij, I can enter from top or left and down or right, the best value of a path passing through the element at index I comma j. So after that, what I am doing is I'm iterating over all indices from 0 to m, and I am applying source at that current index. So what I am seeing is that if already the best value containing uh, like how the value will change if we have already a best part the sum of a best path containing element aij. If I change this value to minus aij, what will happen is that initial sum minus ai in aij will become minus aij, right? So simply the new value will be initial sum minus 2 into aij. So that's what will happen if I am going through a path that contains aij, and here if I am going through a path that does not contain aij, I am taking the left value and the right value. If I am passing through the left of the current index, this will be the answer, and right of the current index, this will be the answer. And I am taking the maximum of these two values. And finally, the answer will be minimum of all possible answers. And I am printing it. Mm, that's all.